This morning you heard a lot about homeostasis, about feedback, emergence, our self-awareness, and these things. They were first actually conceptualized and studied by cybernetics almost 70 years ago. I strongly believe that cybernetics can help a lot in dealing with things, in understanding things. That's why the last one is my favorite definition. What we need to understand today are three simple concepts: that of state, transformation, and variety. And we'll start with transformation. What is transformation? Here is an example of transformation. It is basically a change of state. In this case, from an unhappy state to a happy state. It is a desired transformation when it comes to us, to the loved ones, and in the business context, to our customers. But let's for a moment not look at it for what it stands for, but for what it is. We can see the symbol itself as composed by several, as they call it in cybernetics, transitions. Several transitions. The change of their microstate changes the macro state of the bigger system. And for that, I will use one of the definitions of the fathers of cybernetics, Ross Ashby, who says that, in fact, a state is something that we can recognize if it occurs again. And there are two important consequences, at least two important consequences of this. First, state is relative. It depends on the observer. And second is, a state is not necessarily static. It could be also dynamic. We cannot control, we cannot influence, we cannot regulate unless we have the same variety. We don't, this M in the middle is for management. We don't do this with bare hands. We use different tools, we use organizations, and we use processes. So if we have a process sphere around the management, actually the processes themselves do the same. They have a lot of attenuators and a lot of amplifiers to deal with the environment. And inside, we manage processes also by increasing our variety and reducing the variety of processes until we reach the level that we can manage. And that's not flat. That's not one level. That's recursive, that's fractal. If we look inside and zoom into processes, what we can see that there are many loops, many of filters and attenuators, one inside the other. I said, yes, so what? But you'll talk about, yes, I'll talk about it. So it's a good question, why BPMN? I'll try to give a simple answer. Although it has many issues, it's absolutely unprecedented achievement as something that made a lot of vendors support it, and that achieved for a short time serious adoption rate. So that's the good part. What's the bad part? The slide will not be sufficient, but there are a lot of problems with semantics of many elements like lanes, gateways. There is no time animation. Data and rules are not well represented. Although there are many elements, still there are a lot of patterns that cannot be shown this way, and it's not suitable for knowledge processes. So let's free ourselves from the task. Let's see what will happen. The first thing what will happen is there's a lot of complaint about the big cognitive load of BPMN. There are 120 or more symbols. So it's a fat notation. What we can achieve is to have it a bit leaner. So first small result, but quite a good one, I think. And the second is, I believe that taking tasks out BPMN will be able to absorb more variety. And already, it's proven to be the case. But it will be a pity if we stop here, just with modeling. So let's see what we can do with execution. And for this, we go to the semantic line. Why considering semantic technology? Now, I'm really proud of this slide. Why? Because I hate bullets. And there were about 10 of them before. So with a lot of effort, I reduced them to two main. I will not have the time to explain all the benefits of that. But the first thing is that these technologies are open. What do I mean by open? One thing is that they have the open world assumption. They assume that by default the knowledge is incomplete. All other paradigms, relational database, whatever, they need a place to store things. If something is not set to be true, it's false. Here, if something is not set to be true, then we don't know. After, we can add more information. We are free from the schema. It's open in every direction. It's also the best thing for linking data, using the open source data idea. And it's also very natural. Everything is expressed in a language that is very close to the natural language. Everything is triples, subject, verb, object. The data is described that way. The schema is described that way. We query the data using the same graph approach. We also apply business rules using that. So the same, we just build ontologies and use them all the time. And also rules are a natural part of the language.